Hi everyone, we are going to be continuing our topic digital pins as input and output over here, and we are now going to look into the command that is being used for writing a digital signal using the Arduino. So what is this digital write pin over here? So this is the keyword used for writing a data through the digital pin to the outside world. It could be any device over there. For example, it could be a DC motor, it could be an LED or whatever device available. So write a high or a low value to the digital pin. That is what this digital write means. If the pin has been configured as an output pin with the pin mode, as I told you, pin mode is the one that is determining whether your pin is an input or output. So the pin has been considered as output. Its voltage will be sent to the corresponding value. Either it could be 5 volt for a 5 volt Arduino, or it could be 3.3 volt for a board that configures on 3.3 volt for high, and 0 will be considered as ground or low. Okay, so that is the consideration. Okay. If the pin is configured as an input, digital write will enable high or disable low the internal pull-up on the input pin. It is recommended that if you use the input pull-up to enable the internal pull-up resistor. So in digital write, if you want to initialize the pull-up resistor over there, and that is when you will configure this as an input pin. Normally, you understand that writing means sending an output data. So at that particular time, you will have to be using this particular digital write signal. If you want to take input from the outside world to the microcontroller, you'll be using the digital read signal, which we'll be looking into later. So this is syntax over here. Digital write. You have the pin number followed by the value that is to be specified. So pin value is 0 to 13. Any one pin number you'll be specifying over there, and the value, whether it is 0 or 1 or low or high, whatever value you'll be specifying it over here. As a parameter pin, pin number you will be specifying over there, and the value could be high or the particular low. And this is the example code that is provided for a particular digital write pin over here. This code makes the digital pin 13 an output pin and toggles it by altering between high and low at every 1 second. So I'll be explaining to you how it is working for that every 1 second. The analog input pins can be used as digital pins also. So you have A0, A1, A2, A3 up to A5. Those pins are not only for analog pins, they can also be used as digital pins also. The exception is that the Arduino Nano Pro Mini and Mini A6 and 7 pins, which can be used only as analog pins. Okay, so please understand, for these microcontrollers alone, A6 and A7 are dedicated only for the analog pins over here. Okay. So we look into this particular code. Void setup. Setup is the place in which the program is going to be executed only once in your particular entire program, and void loop is the case where it is going to be executed again and again infinite number of times. Okay, so setup, void setup, whatever you give inside is going to be executed only once. Whatever you give inside void loop is going to be executed infinite number of times. So the declaration part is specified in the setup. Whatever variables you have, you will be declaring them above the void setup. And the integer variables, the character variables, all the declaration data types will be specified above the void setup normally. Here we do not require any such variables, so we are just going to directly go into the pin mode. As I told you, pin mode is the one that is used for declaring whether you are going to use which pin and what is it going to be. Either is it going to be an input pin or an output pin. Okay, so please understand the difference between pin mode and digital write. Okay, pin mode is configuring the particular pin, and either it is an input or an output. So which pin number are you using, followed by the input or output. So here I am going to glow an LED on pin number 13. That is the work that I am going to be doing on here. So pin number 13, I am going to glow an LED, which means to glow an LED, a data should go from the microcontroller to the output. So it is an output pin over here. So it sets the digital pin 13 as the output over here. So I declare it once. That is sufficient. So I put it in the setup part over here. Now coming to the loop part over here. So pin number 13 has now been enabled over here as an output. Now what should I do? I should glow the LED pin connected to pin number 13 or the inbuilt LED. I should glow it on and off every 1 second. Okay. So high means on, low means off. I've told you that earlier. And what is the command used for that? Digital write. And what is it? How will you do it? You have to first specify the pin number, then you'll have to specify what is the output over there. Is it going to be high or is it going to be low? So first you will be giving this digital write 13 comma high, which means that my particular LED is going to be on now. And if I give a delay of 1000, it means that 1000 milliseconds over here. 1000 milliseconds is equal to 1 second. So if I give a value of 1000, it means 1 second. If I give a value of 2000, it means 2 seconds, and so on. So my consideration is over here, every 1 second, I'm going to make sure this particular value is going to be toggling in the LED, high and low. So for 1 second delay, it is going to be high. Okay. After that 1 second, what is going to happen? This particular digital write value is going to be low. So which means the pin number 13 is now going configured as low, which means it is off. So after that, I'm going to give again another delay of 1 second over here. Now, after this 1 second is over, as I told you, it is going to execute in the form of a loop. So it is going to come back to the first line over here and start executing it again and again over here. So after the execution of first line, it is high, and it is high for how long? 1 second. So until this 1 second is over, it will not execute this particular line over here. So that is the use of this particular delay function. Okay. So delay of 1 second over here. Now after this third line is executed over here, it is going to be LED is going to be low, and this low needs to be retained for 1 second. So I need to give a delay of 1 second over here. So you can try changing the delay values and try understanding how you can control the on and off timing of your particular LED. That you can try it on your own by using the Arduino IDE software. Okay. So I hope you're clear with the digital write. We will move on to the next statement, which is the digital read. So reads the value of a specified digital pin, either high or low. So it is going to read a particular value from a particular sensor. The capacitive touch sensor, which we saw earlier, is an example for this. Touch sensor. When I touch it, it is giving a signal. When I remove my hand, it is going to give another signal. But when you consider your LDR, it is not going to be considered as a digital value because it is analog in nature, continuous value. So depending on my particular intensity of light, it will start from brightness and go all the way down to dimness over there. So this range is going to change over there. So that we need to consider. So the LDR cannot be used as a digital read value, but your particular basic touch sensor can be used as a particular digital value. Syntax, as in digital write, it was digital write pin. Here you're going to use digital read pin. You do not need to specify anything, any other detail over here. What is the value, low or high or whatever, because from an output you will not know what is it. Either is it low or high. You need to read that value. So pin comma no other value will come over here. Okay. So please remember that. Don't get confused. So parameter, the pin, the Arduino pin number you want to read. So that is what you're going to specify in this pin number over here. Next one, return. What will it return? It will either return a value of high or low. In digital write, you will specify the high or low value. In digital read, the high or low value from the sensor is the one that is going to come outside. So what is going to happen in this particular code? What are we doing over here? We are setting pin 13 to the same value as pin number 7 declared as an input. So we are going to duplicate the value of the value or replicate the value of pin number 13 onto pin number 7 here. That is what we're going to do in this program. So we have the same void setup and we have the same void loop over here. So what are we going to do? Pin number 13, some values over there. I need to put it into pin number 7. So what am I going to do? I need to create a variable for that. So whatever is there needs to be stored in a variable so that that variable value can be moved into pin number 7 over here. So that variable declaration part is what I'm going to do above the void setup, as I told you over here. So I told you that my first variable is LED pin, that is pin number 13. So whatever value is in that particular thing is initialized over here in the first part. Then whatever value I want to specify in pin number 7 is declared in this particular integer value over here. Next, I have a variable that is value that is going to be moving the value from pin number 13 to pin number 7 over here. That is my next consideration. Okay. So now I'm going to declare which is my input and which is my output. I'm moving the data from pin number 13 to pin number 7. So which means my 13 is going to be my particular value of output. It is outputting a data, and 7 is going to get that input data which is in 13 and replicate it. So this pin number 7 is going to be my particular input pin over here. You can see that in the example in the code over here itself. So pin mode is declaring the pin. What is LED pin? Instead of 13, I'm going to use LED pin over here. That is the only difference. Okay. If I did not give these two lines over here, I will have to give in the place of LED pin, I have to give pin number 13. And in the pin mode over here, if I did not give the second line, I have to give 7 over here. That is the difference. So what is this two lines representing over here? In the place of 13, which I'm going to use inside, I will be using the term LED pin. And in the place of 7, I'll be using the variable in pin over here. That is the concept. Okay. So my particular output, pin number 13 length, one output is coming and it is being put into pin number 7. So what is going to happen over here? I'm going to declare my pin number 13 as output. And what is going to happen next? In my pin mode, I'm going to declare my input over here. So what is going to happen? Pin number 7 is declared as my input. What is pin number 7 called? In pin. So in pin is declared as my input over here. And what is my next consideration? First, I'll have to read the value of pin number 13 and read that value and put it into a temporary variable which is called as value. So that needs to be done over here. So value is a variable that is declared for reading the value of pin number 13 and putting that value into pin number 7. So initially I'm going to declare it to 0. I'm initializing that integer value to 0. I'm declaring it as an integer data type, and I'm going to declare that value initially to be 0. Okay, it could be initially 1 or whatever. I'm going to predefine it to a value 0 here. So what is the next step that I'm going to do over here? In that value variable, what am I going to put in the value of pin 13? So pin 13 is related to LED pin. So I need to read the value of LED pin over here. So I'm going to use digital read syntax over here. So digital read input pin. Whatever is the input pin is going to be read and put it in the value over here. Now what am I going to do? I need to put it in pin number 7. This val could be either 0 or could be 1. I need to store that in pin number 7. If I need to store a value into an output, I need to use the syntax of digital write over here. So digital write, what am I going to do? I'm going to use the particular LED pin over here. So whatever value is in this particular value will be put into this value over here in this particular part over here. Okay, so this is what is happening over here and it is put as an output. So the concept over here is a value of pin number 7 is put into pin number 13 over here. That is the concept that is happening in this video. So I hope you are able to understand the digital read and the digital write principle using this particular syntax.